So you've probably heard this term thrown around, object-oriented programming, or OOP. And if it's always sounded a little intimidating, well, you are in exactly the right place. Today, we're going to break it all down using some simple, everyday ideas. Let's jump in.
And yeah, let's be real, it totally feels that way sometimes, doesn't it? It sounds like this big, scary monster hiding in the code. But I promise you, by the end of this little explainer, you'll realize it's not a monster at all. It's more like a really, really well-organized toolbox. So where do we start? Well, we're going to start by talking about cars. More specifically, the difference between the plan for a car and an actual car you can drive. This one idea, this is the absolute foundation of everything in OOP. It covers the two most important building blocks, classes and objects. That's it. Seriously, that's the big secret. A class isn't the thing itself, it's just the blueprint. Think of it like a recipe or a set of instructions. It just defines what something is supposed to be like and what it should be able to do. And this is where it really starts to click. Over on the left, you've got the class, the blueprint. It just says that any car we make has to have a color and an engine. It doesn't say which color or what kind of engine. Then on the right, you've got the object. That's the real thing. This specific car made from that blueprint is red and has a V8 engine. You see, you can take that one single blueprint and create millions of unique, individual cars from it. And here's what that blueprint looks like in code. See? Not so scary, right? All we're doing is telling the computer, hey, I'm making a template called car. Anything we build from this template is going to have a property for color and another one for engine. And just like that, you've made your first class. Okay, so making blueprints is cool. We get that. But what if you want to make a specialized blueprint that's based on one you already have? Well, that brings us to our next big idea, which is a lot like passing down traits in a family. So the official term is inheritance. But really, it's all about being efficient. It's about not having to start from scratch every single time. You can just have a new blueprint automatically get all the features from an old one. Kind of like how a kid gets traits from their parents. This is just a perfect example of how powerful this is. We start with our basic car blueprint, right? It's got an engine, it's got wheels. Now, when we want to make a sports car, we don't draw a whole new plan. No way. We just say a sports car is a kind of car. So boom, it automatically gets the engine and wheels. Then we just add the one new thing that makes it special. In this case, a spoiler. Easy. And here's the code. It all comes down to that one little word, extends. That's the magic. It tells the program that sports car gets everything, all the properties, all the abilities from car. We didn't have to rewrite a single line of code for color or engine. We just got it for free. For keeping your code clean and reusable, this is a total game changer. All right, now for the idea that sometimes trips people up, but trust me, it's something you already understand intuitively. We're going to call it one name, many actions. It's basically the idea of giving the exact same command to different things and having each one respond in its own perfect way. Now, the fancy $50 word for this is polymorphism. It literally just means many forms. It sounds all academic and complicated, but I'm telling you, you use this principle all day, every day. Let me show you with a super clear example. Just think about that for a second. The instruction is identical for all of them. Start your engine. But the result, well, that's going to be totally different depending on what you're talking to, isn't it? And here we go. One single instruction, start engine, leads to three completely different sounds and actions. The car purrs. The truck gives you that deep diesel rumble. And the electric scooter? Just a silent little hum. Each one of those objects knows exactly how to perform that action in its own unique way. That right there, that's polymorphism. It's what makes code feel smart and flexible. And what's really beautiful is how simple the code is. Just look at it. The command is the same every time. Start engine, center. You, the programmer, don't need to worry about the messy, complicated details of how a diesel engine works versus an electric motor. You just tell it what to do, and the object itself figures out how to do it. So, blueprints, family traits, one name for many actions. It's all interesting stuff. But if you're a busy person, you're asking the most important question right now. So what? Why does this actually matter for me and my team? Well, OOP isn't just theory. It is a practical strategy for building things better and faster. This right here is the bottom line. With inheritance, your team stops reinventing the wheel, so development is just plain faster. Maintenance becomes a breeze. Imagine you find a bug in the main car blueprint. You fix it in that one place, and poof, it's automatically fixed in the sports car, the truck, and every other vehicle you've built from it. And polymorphism keeps your code flexible and easy to understand. It just makes your entire project a logical, organized system.
So, we'll leave you with this final thought. These ideas of blueprints, of inherited traits, of one command having many different actions, they are absolutely everywhere once you start looking for them. You know, a restaurant menu is like a class, and your specific order is an object. Think about how different animals all move, but in their own ways. So, where do you see these patterns in your own life? Thinking about that is really the best way to make all of this stick. Thanks for tuning in.